Number 997, find the town judge. In a town, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody except for the town judge trusts the town judge. There is exactly one person that satisfies property 1 and 2. You are given trust, and a way of pairs trust survive is you go to A to B, representing that the person labeled A trusts the person labeled B. If the town judge exists and can be identified, return the label of the town judge, otherwise return -1. Okay. So clearly they're setting this up to be a graph problem. There's an edge from A to B for each of these inputs. And yeah, I mean, it sounds straightforward, maybe. Yeah, so you just have to check each node to see if there's an out edge, and if there's an out edge, then it cannot be town judge. Is that sufficient? Oh, and I guess everybody has. So it's like a weird star graph type thing. Not sure quite how to kind of. Yeah. Because there's no, what I was thinking is maybe there's some like weird transitive thing, but it's as the problem is stated, it just seems very straightforward. So I'm just going to do a full, yeah. Okay, I mean, I'm going to just do what I feel like intuitively, which is what I said, which is, I mean, we just do a for loop for these things. I think the thing that maybe the optimization that I think off my head, n is less than 1,000, or sorry, yeah, n is less than 1,000, so that's n in this case is v, which is the number of vertices. Trust that length is less than 10,000, which is the edge. Yeah, so I think if you do something like v times e, then maybe it runs a little slow. But if you do something like v plus e, it should be okay. And we could do something with v plus e just by processing all the edges by putting them into a set or something like that. Yeah. Should be okay. And you might not even need to put things into a set, because as soon as you notice that there are two possible judges, you could return -1. So you actually only need to keep track of one thing, maybe. Oh wait, no, okay. So you can trust. So everyone could trust other people that's not the town judge. So I was wrong. Okay. So in this example, you could do one. Okay, person 1 trusts both 3 and 4, but only 3 is the town judge. Okay. How do I want to do it? Yeah. So I'll start by process. But yeah, as we were saying, we should pre-process the trusts, which is the number of edges, so that. Oh, hey, AP Hacker, nice to see you again. Anyway, yeah. So yeah, so we could, as long as we do a constant number of times to pre-process trust, I think we should run in time, and then we just do some v plus e stuff. So first we want to test that we want to construct a set of vertices where it could be a possible judge. So we could just even do something like maybe something like that. Um, the phrasing is a little awkward, but what I'm setting here is for each edge in trust, or which, yeah, for each edge, if someone trusts someone, then they cannot be a judge. So it's also set up a little weirdly, but actually, I guess we don't even need a set because it's just able from 1 to n, so we could just have an array of 1,000 elements, I guess. Okay. So this eliminates them. Okay. Try to think the way to do everyone trusts the town judge. I mean, you could. There are a couple of ways to do it. I'm trying to also probably prematurely optimize a little bit. So what I would do is can you do because I want to prematurely I want to optimize a little bit so that we still run in preprocess OV. So for each possible judge, okay, actually, I think one thing we can actually take advantage of is that uh, you know that you require n minus one people to trust you to be a possible judge. So actually, maybe we could, instead of having it to true, we could set it to 0, and then maybe set this to, say, -1. Okay, and then here, for someone getting trusted, we could do something like that. And in this case, now the possible judge should have n minus one people trusting it. So that, and the only case we have to factor in now is just make sure that, excuse me, there are not multiple judges where this is the case. Yeah. Okay. Let me. Maybe I want to slightly defensive program it. It should be okay. I mean, technically this isn't super necessary because if you set it to -1, then it can never be n minus one. But just for clarity and kind of so I could sleep at night a little better, that's why I'm doing it. What am I doing? Oh yeah. Which one is the I always forget which one is the index on this, but so I might have them swap backwards, but we'll take a look first. Okay, so let's see if it compiles with the. Index out of range. What is? Oh, because it's one based. Okay. Int object is an element. Why is this an int object? Let me print it out real quick. Yeah, -1, 1. Oh, I'm just being an idiot. Yeah, okay, well. I think 2 or 3. Okay, 512. Okay, so at least it returns some stuff. Cool. So possible judge array seems okay. Though this maybe should be I plus 1, but oh, whoops. Oh, this is not -1. Okay, so that works for the first one. Let's now try a few more. I guess okay, so everything feels good so far. I think I think with this problem, one of the traps that you can run into is that you have to look at the constraint of the problem. It's very easy to do a v plus g type thing, and yeah, maybe it's 10 million operations. Maybe that's on the cusp of acceptable or not. But if you could kind of do some pre-processing such that it's v plus g, then you don't even have to worry about it, right? Because it's just on the order of 10,000. So I'm going to submit this and hope it's okay. Yay! Okay. Okay. It's actually not super fast, but I'm okay with that. Cool. Oh, so yeah. So I think this one was pretty straightforward. You just have to implement the rules. I think the thing that is a little that you might have to think about is pre-processing the input so that you can do things in v plus e time instead of v times e times. During the interview, I would mention that and make sure that they get your constraint. I would maybe said something like, oh, if for small n's we would do some v times e stuff, which means for each judge, see if it's possible to be, or for each n or each I and n, see if it's possible to do to be a judge, and you could basically do the naive implementation in v times e, and if they give you constraints such that maybe you can do it in a couple of seconds, or it doesn't run in a couple of seconds, then I would do some. I would talk about pre-processing and what the concerns are, and kind of get into it. As for an interview question, I think this is okay. I think this is slightly, probably a little bit on the easy side, but it. Yeah, I mean, I think maybe if there were like slight modification to the problem to make it slightly more interesting, it could be a reasonable difficulty. I think it's a good kind of maybe possibly for a phone screen or something of that nature. You could kind of have that just to make sure that they can code reasonably and have some fundamentals around graph theory, if that's your thing. You maybe ask them a little bit about the complexity and stuff like that. But I think for an on-site, this is probably a little on the easy side. Okay, cool.